Welcome back, everybody. Today we're going to be going through the Pro Cut On-Car Lathe. We're going to be covering the setup procedure for this, showing you how it operates, and then we'll go ahead and machine a rotor using our training stand over here. But the purpose of this piece of equipment right here is to actually mount up onto the vehicle with the caliper off. This machine will actually mount to the vehicle's hub, drive the wheel, and resurface or machine our rotors on the car. So we could do this on the lift. This rotor over here is just for demonstration and for training purposes, so you can see what's happening. Because once we roll this machine into the wheel well of a vehicle, it's much more difficult to see what's going on as far as setup and machining. So this is the piece of equipment we're going to use on modern vehicles today to machine rotors. We'll talk a lot about that in the lesson, but lateral runout measurements, lateral runout specifications are so low today on modern brake systems that we have to either replace the rotors or machine them with this type of equipment that's going to take into account the runout of the wheel, the hub, etc. The equipment itself is mobile, so we're going to roll this into place. The height is adjustable, and so is the tilt. So we can accommodate a lot of different heights as far as vehicle lifts, or if we can get it on jack stands high enough, we can also do it stationary that way. Down below here we have our different adapters. These are identified by serial number and color, and we are going to look these up for each specific vehicle before we mount it. And depending on your lug pattern, how many wheel studs you have, you're going to use a different adapter for different cars. Over here we have the cutting head, and this looks a lot like a standard cutting head for a bench type lathe. So we've got our thousandths on our knobs here that are going to control our cutting tips as far as moving in and out and how much material we're taking off of the rotor. But this table is going to slide back and forth so we can position it and machine those rotors directly on the vehicle. Okay, so the first thing we're going to want to do is use the Pro Cut adapter search, either by scanning the QR code over here, which will take you to their app. We can look it up online real quick, figure out which adapter goes to that specific vehicle. It's just by year, make, and model.
Using the adapter search on the Pro Cut website, we can pull up our year, make, and model and select our adapter that way. Our training stand happens to be a Dodge Caravan from 1997. Select Dodge 97. We can go to Caravan, and we get our listed adapters. So a couple different ways we can identify it. We've got our adapter number 50-688, which is written on the label. See that 50-688. It is the yellow adapter. So between that, we should be using the bolt pattern number 2. Should be this one, second bolt pattern over. That's how we find the adapter for our vehicle.
This particular vehicle, we looked it up in our search, and it told us that we needed the 50-688 adapter. This is a 5-lug adapter. So we're going to use this adapter to mount the Pro Cut machine to the car, and the machine is then going to rotate our wheel and machine the rotor on the vehicle for us. So let's go ahead and get this mounted up to our hub correctly, torqued, and then we'll show you how to mount the machine. Now that we know which adapter fits our vehicle, next thing we need to figure out is what size lug nut we have and thread pitch. So the Pro Cut comes with lots of different options. We do need to use the Pro Cut lug nuts. They're a lot slimmer, and in this case it wouldn't matter too much, but if you have the lug nuts that have a washer attached to them, a lot of times they interfere with the adapter type. So always use the Pro Cut lug nuts. We're going to get our adapter in place and use our speed nuts here that came with our kit. we're mounting the adapters, we want to make sure we don't drop them. No power tools. We're only going to torque these to a max of 50 foot-pounds, but usually we go around 30. We just want to make sure that it's flat. So right here you can see where we would run into clearance issues with our OEM lug nuts, where we need that slim profile to slide in here. Okay, now we're going to go around and torque each lug nut in a star pattern, 30 foot-pounds. Make sure it's flat like the wheel would be on the vehicle. We don't want to induce any run out. All 5 torqued in a star pattern. So now this adapter is mounted to the hub of the vehicle just like the wheel would. That's going to allow us to now mount the piece of equipment, the Pro Cut, to the adapter itself. When we're moving the machine around, we always want to be keeping an eye on the cutting head. There's a lot of precision tools up here that can be damaged if we hit them on anything, and we're going to be working. Remember, if this wasn't a training stand, it was a vehicle, this would be the wheel well. So there's not always a lot of clearance in here, so you have to keep an eye on this to make sure we don't bash it on the rotor or components in the vehicle. Okay, I'm going to bring it up into position, and the way that our Pro Cut's going to mount is this nose cone here is going to go inside this middle circle and help align us. This pin, alignment pin, is going to drop into any one of these holes here. Doesn't matter which one. After we have those in position and we're flat or flush, this drawbar will pop out and has a threaded rod that will thread to the inside of our adapter and finally connect everything together and make it one. So let's show you how that all works right now. So get our height correct, get the nose cone in, align the pin, and then we want to make sure we're flush with the hub, that we don't have an opening like that or down below. Once everything looks nice and flush, we can push the drawbar in and it should thread in nice and easy by hand. Okay, remember, no tools on this, hand tight only. Once the drawbar is tight, the machine is now part of the hub and they will spin together. So our machine is going to drive the wheel, drive the axle, rotate the rotor, and machine it on the vehicle. Our machine's booting up. Just let it go through its startup process. And now we've got our ready light. So once we're mounted physically to the car, the first really important step we need to do is, number one, get the tool tips away from the rotor, okay, and away from any components on the car. We're going to calibrate the machine so it matches the run out of our hub, whether that's the wheel bearing or the axle or both. So we need to get this out of the way and start the machine up and let it go through its compensation process where it reads the run out of the wheel and matches it with the machine. So we're going to roll our table back out of the way a little further. And now I can go ahead and turn the machine on. There's a big main power switch here. At this point, make sure that there's no cords wrapped around your drawbar. And make sure our brake components are clear. Depending on the type of drivetrain of the system, the other wheel might rotate, so make sure our brake components are clear and out of the way over there. Our caliper's hung up on the opposite wheel. We're now ready to turn the machine on. Our main power switch for our motor is right here. So once I turn that on, we'll start seeing our rotor start to rotate. Make sure our feed knob is pulled out, just like that, in the out position. If it's in like that, our equipment will go into automatic feed mode, so make sure that knob is out as well. Right now the machine has not been compensated, so you might be able to see on the camera there should be a little bit of wobble to it, and it's because we have not taken in account of any run out that the wheel bearing might have. In order to compensate for that, the first step we need to do before we set up our cutting tips, anything like that, is we need to compensate the machine. We're going to do that by pressing the start button here. A couple things are going to happen when we press the start button. We're going to hear some clicks come out of the clutches in here, and that's going to begin to read the run out of the wheel and adjust the lathe accordingly to match that run out the best that the machine can. Simultaneously, we're going to see a number over here which is a live lateral run out reading in thousandths. So if it says 7.5, that's 7.5 thousandths of run out. That number is going to continue to decrease until the machine can get the run out under 1,000th. Okay, the Pro Cut will always cut a rotor with a maximum of 1,000th lateral run out. So let's go ahead and do that now. We're going to press our start button. We can hear the clicking. We have 2.7, 3.2. And our machine is making adjustments according to what it reads for our LRO. Okay, we've settled down at 0.3. So that is a 0.3 thousandths of run out. A little bit confusing. Or 0.0003 thousandths of an inch. So our machine is now compensated and calibrated to the wheel. So we are under 1,000th run out. Most vehicles today, a common specification is 2 thousandths allowed run out of the rotor. So we're going to cut this rotor the way it's compensated right now at 1/2 of a thousandth. Our feed knob. So this is going to feed our table in and out. So right now the first step we're going to do is set our off switch. We want the machine to automatically shut off once we finish cutting the rotor. So I can bring them right into where the end of the cut would be done, and I'm going to set my off switch. Okay, so I've got my cutting tips centered. The rotor is exactly centered in between those. This is still loose because we are going to adjust these right now and find the surface of the rotor. You can see on our knobs here, they are numbered. We've got a reference line. So the first thing we're going to do right now is find the surface of the rotor and set that knob to 0 to tell us that is our starting point. And markings on our knobs are every 2.5 thousandths. So 0, then we would have 2.5, 5, 7.5, 10 thousandths. And that would be the amount of material that you are machining off of that side of the rotor. So if we take 5 thousandths off each side, we will be removing 10 thousandths of material total. Okay, so right now we are going to find the surface of the rotor with the scratch cut and set those knobs to 0. Okay, so we've got our machine compensated. I'm now going to start it up, and we're going to bring each cutting tip in slowly, and as soon as it scratches the rotor, we're going to stop and set our knobs to 0. I'm going to start with the inside knob. I'll just roll them in nice and easy. Easy does it. We don't want to ram the tips into the rotor and cause damage. We don't want to break the tips or scratch the rotor deep. Okay, so I'm going to roll my knob in until I make contact with the rotor. I'm keeping an eye right here. Nice and slow, easy does it. There's contact, we're going to make that our 0. And come over to this knob. I'm going to pull it out. and set that as our 0 point. Okay, and I'm going to do the same thing with our inside knob. Move that cutting tip in nice and slow so we make contact. There we are. Let's set this knob to 0. And now we know that we have the surface of the rotor on both knobs. From there we can adjust how much material we're going to take off of both sides. So I'm going to roll the knobs out just a little bit, bring our tips off the rotor. I can go ahead and bring our table all the way in. We don't want to drag them across the surface of the rotor. And take it in as far as we can. We want to make sure we don't leave any material behind. So we're going to take it all the way to the inside here. We want to make sure we don't hit the hat of the rotor. So keep an eye on it when things get close. Right about there is the inside. Now we can go ahead and start the lathe back up. We're going to bring our knobs back to 0. We do have some taper on our rotor there. A lot. Bring our other knob back to 0. And now we can determine how much material we want to take off of the rotor. So in this case, we'll take 5 thousandths off of both sides. We're going to rotate each of these knobs 2 marks. They're 2.5 thousandths each, so we need to see a 5 on the line. 2.5, 5 thousandths. So now move that cutting tip in 5 thousandths. Same thing for our other knob over here. 2.5, 5 thousandths. And now we're moving 5 thousandths from each side for a grand total of 10 thousandths of material coming off of this rotor. Once we've got our settings dialed in, we've got our cutting depth picked, I'm going to tighten this black knob we haven't touched yet, and that's going to lock our cutting tips down into place. Now we can't move these knobs. Last step, I'm going to install our silencers. These are also vibration dampeners, and I'll direct our cutting chips down into the tray as well. So they've got a couple different jobs. These are going to go right on top of our cutting tips. That's what those notches are for. Set of earmuffs. And make sure we do that with the machine off so we don't get our fingers entangled in there. We are now ready to go ahead and machine this rotor. Let's turn it back on. Okay, I'm going to start the machining process by pushing this feed knob in. Now the machine's going to take over and start feeding the table out at a nice slow, steady rate. You can see in here our nice new machine surface. The shiny area, and it's slowly working its way outward. If we were cutting a brake rotor, we want to keep an eye and make sure that we don't have any dark spots, that we're getting through all of the bad material and we have a nice shiny new finish all the way around. We want to check the back side as well. And here on our back side you can see our new shining surface on the inside. And that's also going to correct any run out or disc thickness variation that we have, and bring that back down to 0.5 thousandths of LRO. The Pro Cut can take off up to 20 thousandths per side per cut. That's a lot more than you'd ever need to take off, but what it means is we can get the job done in one shot. We can take off the material that we need to in one machining process and move to the next wheel. As soon as this finishes, tape will slide by our automatic off switch and turn it off, but we're going to want to keep an eye on this while this process is happening. If we were in a wheel well, we would have tight clearances like this, and we would not want the table to be fed into components that possibly damage the equipment or the vehicle. We're nearing the end of our cut. You'll see those earmuffs take off in a second. And there we are. We have a nice, finely resurfaced area here. The Pro Cut leaves a resurfaced finish that's 30 to 60 micro inches. So very, very smooth finish that helps eliminate brake noise, make your brake pads last a lot longer. The only cleanup that we need to do with this rotor is with soapy water and some white paper towels. We don't want to use any brake clean. Soap will help lift these cuttings out of the rotor. You can see we've got some of that left in there. Those silver cuttings, we want to get that up out of the rotor before we put our new brake pads on. So we're going to use soap and water for that to help lift those cuttings out and get them off. Brake clean is great on brake rotors for removing grease and dirt and oil, but soap and water is what we're going to use to get these cuttings off. And the Pro Cut itself, no compressed air. We're going to use a brush to clean off all these filings. Don't spray any compressed air around this. It'll get the filings in the magnetic pickup and can damage the machine. So brush everything off by hand. So let's go ahead and get this machine disconnected. Okay, once our drawbar is disconnected, I'm going to go ahead and pull the machine out of the way, making sure I don't contact anything with our cutting table over here. Okay, just get it off out of the way. We can disconnect our adapter and break our lug nuts loose. Remember, no power tools. Hey, remember, no power tools on our adapter and a max of 50 foot-pounds. Be gentle to these. Hang them back up. Last thing we need to talk about is, because this rotor has been custom machined for this corner of the car, meaning we compensated for how this wheel bearing operated and ran. we need to index the rotor somehow. You can see this mark across the hub and the rotor, so that if this rotor comes off the vehicle, we can put it back in exactly that same position. Okay, if I clock this rotor this way and put it back on, I have just undone a lot of those compensation procedures and corrections that we did when we machined the rotor specifically for this corner of the car. So make sure we mark the rotor. Something else you can do is put a lug nut back on to hold it in place. If we're moving over to the next side of the vehicle, the opposite side of the vehicle, there's a good chance that this wheel could spin when we machine that side. So make sure we've got it either secured in place or marked and removed. But after we clean this with soapy water and paper towels, this rotor is ready to be reassembled and brake pads and caliper installed. So major benefits to this equipment over a standard bench lathe. This is attaching to our hub and taking into account and compensating for any run out that might be present in the wheel bearing, for example. You can have a brand new rotor out of the box maybe that has very minimal run out, but now we go put that on a wheel bearing that has some wear, and that rotor might have some run out when it rotates through the caliper. So this is going to take into account anything like that and compensate for it to make sure that when we're done here, this rotor is within 1/1000th of lateral run out according to our brake pads. Okay. So that's a major advantage to on-car brake. So that's the major advantage to on-car brake lathes over bench lathes. And if you have a modern high-performance vehicle with some high-performance brakes, the specifications of that brake system might demand that you use this type of machine or replace the rotors altogether. All right, well that's it for the Pro Cut. I hope it's been beneficial. It is a complex piece of machinery to get it to the car and what it does, but the setup is pretty straightforward, and the speed here is key. We can get this mounted to the car and we can machine those rotors you saw in under 5 minutes as far as the machining process. So you can move this around the corners of the vehicle pretty quickly and get that procedure done. So, all right, I hope to see everybody soon. We'll catch you at the next lab.